Name of the script file?
Sir?
What is the name of the script file? Script? Okay. Abraham Russell. Okay, thank you.
I have shared, sir, on your personal WhatsApp also.
Okay, sir, thank you.
Yeah, so recording already started. So now I will revise the thing. So now, as we have seen AMI, GG by plot, BLUP, WASSB. So now the last model, last but important, that is Eberhardt and Russell model, which is based on regression. As we have seen earlier, yesterday and day before yesterday's, we are using mixed models. That is based on fixed and random effect. And now this Eberhardt and Russell model is based on regression analysis. As in this Eberhardt and Russell model, we are studying the deviation of performance of genotypes across locations from their mean performance. So to study that, we'll use the regression model. So now, just I have taken this data that everyone is well familiar. First is environment, second column is genotype, third column is replication, and total 18, C1 to C18. Total 50 genotypes, 3 replication, 4 environment. So just I will save this data. After that, I will come everything again. So I will open this R Studio. Then, as today is the new session, again I will set the working directory. That is, working directory is set as desktop is my working directory. After that, I will input the data file. So same, name is stability. So here you can see data file is imported. So after that, to get the Eberhardt and Russell analysis, we need 3 packages. First is Meton, second is ggplot2, third is write Excel. So all 3 packages are already installed on your system. Yesterday, some participants having problem with ggplot2, so I told the solution to install the scale package. So simultaneously, ggplot2 and scale will solve the error whatever it will come. So as these all 3 packages are already installed, I will run this library for Meton, library for ggplot2, and library for write Excel. Okay. Then after that, to get maximum print in this environment, we'll use this command, that is option maximum print equals to 10,000. So here we will use this first command based on regression. Yesterday also same command was there, but the model is mixed model. Here we are using G into E with regression. So file name is stability. Here environment, genotype, replication, and your first character. Everything will be same. So just enter, evaluation done. So you can see here, regression analysis, regression parameters. We'll come to that. First, let me finish everything. So now, regression ANOVA for the trait C1. So this is the regression ANOVA, that is ANOVA for ANOVA of Eberhardt and Russell model for the trait C1. Then here we will calculate the regression. So here you can see, actually, this command will give you both things. If you want separate, just you can use these two commands. Then now this we will plot this regression. So this type of representation will come. All these 15 genotypes. After that, now we need to import this in Excel. So same like we did for AMI, same command. Then as we have already run this write Excel command, so we will directly paste this. After that, here you can see regression ANOVA and this regression values. Both things are there in Excel file. So now from this you can mold it to anywhere. Got it? So run this. After that we will discuss about how to interpret it. If anyone is getting any error, let me know. Like this, you have to follow for each and every character, and then you have to merge all those Excel file into one table. After completion, let me know. So already if you have gone thoroughly to the files what I have shared in the afternoon, one text file is there related to the interpretation. Is it?
Yes, sir.
So just open that text file. So anyone remembers what is meant by favorable and unfavorable environment? Yes, anyone? What is meant by favorable and unfavorable environment?
Stress-free environment is known as favorable environment.
Wherever you will get stress-free means wherever you will get high performance of your respective genotypes. So that environment you will consider as a favorable. Okay. And vice versa, it will be unfavorable. So now here you can see everyone completed.
Yes, sir.
Just open that Excel file, output file, and open the regression sheet. So anyone is getting error?
Yes, sir. I'm sending you on phone, sir. Can you check
Yeah.
from the number 905?
Yes, share. So just you can see here, if you open that file, Eberhardt interpretation one text file I have shared in WhatsApp group. So just open that.
Sir, I have sent you from 905.
Yes. So have you run that library meten command?
Yes, sir.
Library meten ggplot write Excel.
All of them.
That day, madam, you didn't install R tools.
I did, sir. Scales
No, but
also
it is
yesterday only.
still it is showing, na?
So
That means
yesterday
it is
only we
not
read.
installed. That means it's not installed properly.
Okay, sir.
And simultaneously, yesterday you only installed that scale package, na?
Yes, sir.
Yeah, so run library for scale also.
Okay, sir.
Yeah, so here there are three conditions for Eberhardt and Russell interpretation. So first is if your regression coefficient, that is B, if that B is equal to 1, it is suggests that genotype will perform similar in both favorable and unfavorable environment, indicating the wide adaptability of that particular genotype. Second is if the value is less than 1, so that genotype is better in favorable environment only, and if it is if it is greater than 1, then the genotype will perform better in unfavorable environment. So can anyone tell me which environment we have to take, either favorable or unfavorable?
Favorable.
So this stability, so what is missing in this interpretation? So as from this file, you will come to know that it is depend on the regression coefficient value, but something is missing. Something is missing here.
Yes, sir.
Can anyone
Mean
tell me?
performance. Mean
Yeah.
performance.
Right. So your regression coefficient is 1, less than 1, greater than 1, all it's fine. But if suppose, just you can open that output of Eberhardt.
Sir, how do I go to the output file for Eberhardt? Where is it?
So
Is it
sir,
in the
it will
C?
come to your working directory.
Okay, sir. Thank you.
One Excel file, just see the name regression stability TP.
Okay.
So number ending with 417. Aniket,
Yes, sir. Yes, sir.
just download. You 2 days before you downloaded, na, right Excel.
Yes, sir.
Then just simply run library for that particular package.
Okay, sir.
So just see here. So everyone please open that output file. So see, there are multiple options, multiple parameters are there. That is genotype B0, B1, then T, then P value, S square DI, then F value, then again P value. So their number of parameters are there. Yeah. So now here see, this is the first most important. This thing is S square DI. So S square DI is what I already told, the deviation of your particular genotypes from your mean value. So mean value means what? Just you have to take the mean, total mean of your pooled data. Not just it's like a E1 mean, E2 mean or E3 mean. Just you have to pool that environmental data and you have to compare this mean value with this performance across the location. And then second is this B value, that is your regression coefficient. So now, how will you interpret this if suppose this genotype 1? So if the mean value of this genotype 1 is greater than mean of all 50, if mean value of genotype 1 is greater than the overall mean, and then coefficient of regression is 1, and as you can see here, deviation is in minus 0.01. So that is just, that is approximately is negligible. So that deviation is less. So mean of genotype 1 is greater than overall mean. Coefficient is equal to 1 and less deviation. So that means you can say this genotype is stable across the location. It is widely adapted genotype.
Yes, sir.
So that is the interpretation. Simple way. So like this, you have to interpret, you have to do interpretation for all the 50 genotypes. For all the 18 characters. This is just for C1. So still anyone is having any error with this? Up to this?
Sir, from where we get environmental index?
Yeah. So up to this any error? Then I will proceed to that environmental index.
The number ending with 417.
Just 1 minute. Give me 1 minute. So here you can see number 417, Aniket. Right Excel. So whether you have installed, whether you have run library for Metin and ggplot2?
Yes, sir.
Aniket?
Yes, sir.
Your packages are installed. This already this Metin, ggplot2, all these packages are there on your RStudio.
Newton and ggplot2 are installed, sir. And I have run library for them.
What is the name of your input file?
Uh, stability D. So, stability D, sir.
Here you are running command with only stability name.
Okay, sir. I will.
So there are, after this two, we'll go with one by one variable, then we will proceed finally environmental index. So first is B0. So B0 is the mean value of your character, individual genotype, and for comparison, you need to calculate the overall mean. So here overall mean is 3.62. So if any genotype is having more than 3.62 mean value, coefficient is 1 and less deviation, so that genotypes are well stable and adaptable genotypes. So next, as I already told you, B1, that is your regression coefficient, that is responsiveness to environment. Then this is the t-test value. Then this is p-value for the particular t-test. This is your deviation from regression. Then this is f-test. This f-test, it is there to test the significance of deviation. Then next column is p-value for the f-test. Then this next is RMSC. This is a root mean square error. RMSC means root mean sum square error. It will check the accuracy of the model. And last is R square. It is nothing but coefficient of determination, that is goodness of fit. So here there are two parts, stability, and we have to find stable genotype and adapted genotypes. Fine. So stable genotypes, I told you, more mean, coefficient 1, less deviation. And adapted genotypes means what?
So can you repeat what are the stable genotypes?
Stable genotype means the mean of genotype should be more than overall mean. Overall mean, just I calculated this, 3.62. So if any genotype is having more mean, likewise this 3 number will take 4.19. This coefficient should be approximately equal to 1 and deviation should be less. So that is called as ideal stable genotype. Now,
Okay.
part 2 is adapted genotype. So adapted genotype means if this B1 is, as here I told you, if B1 is less than 1, so genotype will perform better in favorable environment. So that is adapted to that particular environment only. That is called as adaptability. That is the difference between stability and adaptability. And if it is greater means it will perform in unfavorable environment. So that is the difference.
Can you repeat, sir?
Which one? First one or second one? Stability or adaptability?
Adaptability and stability both.
Adaptability is same as I shared the file. Text file I already shared. So that is nothing but adaptability based on regression coefficient. If you add in that regression coefficient your mean value and deviation from regression, it will give you stability. So up to this, it's fine.
Yes, sir.
So now, last part of this means, what about environmental index? Okay, so here you can see in the graph, all total 50 genotypes, right? On this x-axis, environmental index are there. And in y-axis, responsive variable means the values for your trait, that is C1. So from this graph, like you can see, this is 0. And this side minus, this side plus. So whatever now see this, all these values are negative. So the negative values means the environment is poor. 0 means average and positive means favorable. Now you will say, where are the values? So now if you have to calculate the index, if you can note down, if you have to calculate the index, you have to subtract the mean performance, that is, you have to subtract the overall mean from the performance in each environment. You got it?
Yes, sir.
Yes, sir.
So what you have to subtract?
Mean performance.
Overall
Performance
mean
in
of
each
all
environment.
the genotypes. Overall mean of all the genotypes from genotype performance in each environment. So that values you will get, that values is related to your environmental index.
Okay, sir.
And this is the representation. So this is about Eberhardt and Russell. So now to make the things lighter, we will go for some diagrammatic representations like box plots and everything. Just so anyone still having error with this? Just in 5 minutes you can tell me.
Sir, in starting you told that to sort the columns. So first we will sort it.
No need. Actually, just for the blob we arrange according to the genotype and replication. No, so that's why I told. But already we have this data, no?
Yes, sir.
Yeah. So just data arrangement is similar like AMI model.
Okay, sir.
Yeah. Only for blob and WAASB, this we have arranged like 1, 2, 3 instead of 1, 2, and 3 continuously.
Okay, sir.
Sir, one dot, sir.
Yes.
So, sir, degree of freedom will be 1 for environment in this.
How?
In linear, sir, we get that.
Environment linear means what?
Only environment.
Yes, anyone? What is meant by this environment linear? So actually, your environment linear means your regression component. So for that, your degree of freedom will be 1. So here you can see the sum of square and mean sum of square, both values are same. Is it?
Yes, sir.
So that is nothing but your average value, one single value, average value of that particular trait. So here genotypes are 50, so DF is 49. So here 4 environments, 50 into 4 environments, and then this is linear, so 50 for minus 1, and then full deviation is 100. And these are your mean square, MSS. And at last, error is there.
Sir, please take number ending with 417.
417. So just to do one thing, Aniket,
Yes, sir.
close everything, close R Studio also, and start from 0.
Okay, sir.
Yeah, so next is we'll go for violin script. So just save the data and open the violin script. So now here, just you can open the data. So here there are different columns. Likewise, first is genotype. Then second is type of population, that is there are different crosses. In BC1 F1 generation, there are different crosses, and all these are the parameters. So from of this diagram, of this table, we'll go for the representation of these numbers. So for that, just clear with the broom, as if working directory is already set, and just see here, this violin file is in CSV format. Okay, so just we need to import that file with one simple command line. Just see, I am typing. Just you can see here, the data is already imported with that one line command. Everything is there. So after that, already this GG biplot is there. So we have run earlier, but still I am repeating it. No problem. Then just you have to set the theme. Then we'll initiate this. So this is just initiation, so don't worry. The diagram, the graph will come. So if you copy this, so here just you can see the graphical representation. So this plot is called as violin plot. Just everyone can try. Just to read this file, just see.
Sir, what is
Yes,
this
madam?
for? Sir, what is this for? Violin plot. Sir, I have never heard before.
Suggest this is to make your data something impressive. Because
Okay.
already you have the data table with you. So for conventional core breeding, it's fine with this data, but according to new, we need something new representation. So this is just kind of representation.
So, sir, it is for backcross data only.
You can include your data, you can try with your data also.
Okay, sir.
It is not a thumb rule that it is, I have shown for this population, so it is like that.
So where is the
Different
coding for this violin?
It is in group. WhatsApp group, it is already there. Some 7-8 files I shared, no?
Yes, sir. Sir, out of that, which files are named?
Last file, script. Last file is script, and before script, last CSV file. Here you can see the screen. So to import the data, you can use this highlighted command. Use this and run this. So let me know after completing. So it's done.
Gopalji,
Yes, sir.
uh, how we import this CSV file?
Yes, sir.
Directly?
I have highlighted this command. I will paste in chat box.
Sir, this script for violin is not working for me. I have downloaded but not working. Sir, can you please paste this in WhatsApp?
Yes, sure. So this is the first command to import. After that, library. Next, you have to set the theme.
Excuse me, sir.
Yes, madam.
905 की query देखिए sir.
1 minute, 1 minute. That codes are not working with you?
Yes, sir, it's not working.
I have shared in WhatsApp group. Have you, madam, before giving this command, whether you have set the working directory? Everyone, those who are getting the error that is on my screen, no such file or directory. So just first set the working directory and then run this command.
Okay, sir.
Devanshu, use this command I have shared on WhatsApp.
Okay, sir.
Aniket,
Sir, that first line we have to use it before or after the import, because when I am importing my file,
which first line?
sir, here in coding you have sent now, sir, that violin read.csv.
No, don't use the text file command. Whatever I have shared in group, use that.
Yes, but the thing is, sir, we have to first use that line and then we have to import, or before import only we have to.
See, madam, in WhatsApp group, open it. This first line is there now. Violin read CSV,
Yes, sir.
violin.csv. So with that command only your data will be imported.
Sir,
No need to import the data separately.
Sir, working directory set करने
Okay,
के बाद command लगाया फिर भी नहीं आ रहा.
So your file name is same?
Yes, sir.
What happened? So just madam, do one thing, save that CSV file in Excel.
Okay, sir.
Open that CSV file, save as in Microsoft Excel format. And try to import from this import dataset tab.
Sir, I have shared one screenshot number ending with 157.
Yes.
Sir, I'm not getting that violin plot. It's blank.
Not blank, just proceed. See,
Okay,
see
sir.
the screen, see the screen. Like this you are getting?
Yes, sir.
Yeah, when you will run the last command, you will get the plot.
Okay, sir.
Yeah. So in this, it will just build a base. And after that, finally, it will give the plot. So just you can do this for the respective, this means you can do this for other characters also. Yeah, Aniket.
Yes, sir.
Yeah, it is something your system issue. Just check the updates of softwares.
Okay, sir.
Just check it. From tools, there is a second option. Check for package updates.
Yes.
Go to tools. There is a second option. Check for package updates. So something is there in that only. Yeah, Asifa. Okay.
Which package I should select
Your voice
for
is coming in
installation?
echo. Your voice is coming in echo.
Sir, I have sent the photo. Sir, which package should I install?
1 minute. So here, number ending with 77, last numbers.
Sir, 417.
So number 1 minute, just number ending with 77, last 2 digits 77. You miss one bracket. So because of that, it is showing error. Please see this command. Number ending with 852. You miss this bracket. Just see the screen. You miss this bracket. Yes, correct, Rishabh. Okay. So this is violin plot.
Sir, number 417.
Some issue with your system. Just give me a call after that.
Okay, sir.
Sir, kindly show your R Studio that
Yes,
coding.
yes, 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 yes. So yeah, if you have completed, just see this plot. So on x-axis, you will get the type of population. So in our case, it is crosses, VC1 F1 generation. And in y-axis, the trait, primary branches per plant and the values. Okay. So here, this middle line is nothing but the median. So middle line is nothing but the median. Then this box height. Box height is nothing but the interquartile range. Then here you can see the some shapes of the violin. Some are wider, some are narrow. So what it indicates means, whatever the particular crosses are there, if violins are wider, it is suggesting more phenotypic variability in present in those crosses. So more phenotypic variation means it is a more effect of either genetic or environmental level. So more variation is there. That's why this violin shape is wider.
Sir, this is also a part of stability.
No. It is just a diagrammatic representation. Stability chapter over.
Sir, means when we can use this kind of plots for which analysis?
Anytime, madam. If you have data, you can use any plot. Either heat map or this violin box plot, your normal bar plot, anything. This is just a representation of what data you have. That's it.
Okay, sir.
Sir, you told today you are taking diversity cluster.
Wait, have some patience. We have still 2 more days. Today is not the last day.
Okay, sir.
Today is not the last day, as we have rescheduled our last 2 sessions, so that 2 sessions will be covered. Still, after this, heterosis combining ability and genome-wide association is there.
Okay, sir. I think it is last date. That's good.
No. Yesterday only Dibakar sir told, no? Today is not the last day, don't worry.
Okay, sir.
So then next, we will go to heat map. Open the heat map and cluster. And save this data to the Excel file name as data2 in your working directory. And see this now. Here also, library ggplot2. Then I will make that command short. Just see on the screen. As our file name is data2, I am running command, but I forgot to import. And no one is reminding me. Yeah, so this is simply the mean values for the 12 characters. So this is the data. Simply we'll give heat map command. So we'll get the heat map. Now if you can see this command on screen, just run it. Use the Excel file data2. Use the Excel file data2 and draw this heat map. After completion, let me know.
Sir, kindly repeat the process.
Just here you can see on the screen, madam. First, library ggplot2 as we have already done it. Then just import the data set, that file name called data2. After that, then just a single command is there. Data is equal to as dot matrix, your file name. Then after that, heat map data. As here we have given command that data is equal to matrix data2. So ultimately your file name will be data. So that's why heat map. So if here if you want to change the colors, then you need to install one package that is first see. If you like it, then only install. You can install it later also. R color brewer. So because of that R color brewer, you will get this type of different colors. This is one basic, then this is second. With and without cluster. If you want, you can install this package, R color brewer. That graphs will change, the colors will be changed.
Sir, please just
Your voice is coming in echo. Just can you stop that?
sir, please share that sensor. The code. You don't have.
It is there in WhatsApp group. Evening only I shared that at 4-5 o'clock, maybe around 4-5 o'clock. It is there.
Done, sir.
Okay. So here you can see this is actually heat map with clusters. As actually in our data set, we have 20 genotypes. So this is data heat map with cluster for 20 genotypes. So here you can see there are different colors. So wherever the color is green, it means the value is low. Where it is pink or magenta, so it indicates the higher value. And where it is white or here somewhere at many places you will get the light shade. So that light shade represents the intermediate values. So all these three color gradients are there. So likewise, and these clusters. So on the left side, you can see the clustering of variable. Okay. And observations number are 1 to 12. That is C1 to C12. And genotypes are 1 to 20. If you can see this C4 and C12, these are seems to be closely related. Just you can observe their pattern. The color shades are mostly they are closely related. And here you can see this 6 and this 20. So here on this color basis, you can easily identify which value is on higher side and which value is on lower side. So that is the ultimate of heat map. So number ending with 852 is online. Number ending with 8852.
Yes, sir. Yes, sir.
So I am telling you, you are missing one bracket. So simply because of that one bracket, you are getting this error. Just give double bracket after that. You have type a double inverted comma top. After that, give double bracket and run the command.
Sir, can you show the R console, sir? I want to see, sir. Now.
So just see. I will tell you, see. Like this it is there. Like this it is there or not? So double bracket means you have to give like this. Just
Okay,
this
sir.
bracket, this highlighted bracket you are not giving. Because of that error is there. If you give that bracket, that analysis will be clear.
Thank you, sir.
Devanshu. Whether you have downloaded it from WhatsApp? Devanshu Raj.
Sir. Yes, sir. Yes, sir.
Where you have saved it?
Sir, I have
Where you
saved
saved the file?
Sir, I have saved in local disk D. In the same folder where I am locating part directory.
Then easily you can browse. Just click. If you will click on this browse button, and you can go.
Sir, I am
Wherever
trying a
that
lot.
file is there.
Sir, I am trying
It
a lot,
is
but
simple. What you are trying? See this. No need to try. Why you are trying? This browse. This type of window will open, and you can go anywhere throughout your computer.
Sir, when I am
As
selecting the file, then file is not being selected. This is the problem coming.
So here, like this, you have to select and you have to click. You have to click open. That's it.
Okay, sir.
Sir, can you tell the color changing process again?
So color change, madam, as there are 3 colors.
Yes, sir.
Which one?
Sir, no, not the color analysis, but the code you have kept, na, library R viewer, then custom COL in the R Studio console, sir.
So simply, if you want to change the color, just you have to install this package first, R Color Brewer.
Okay, sir.
After that, run library, and this 3-line command, after that you can use, that color will be changed, as this is our basic first.
Yes, sir.
So we have make it like this, as this is looking something more interactive.
Yes, sir.
So please install that R color brewer. After that, run those commands. So same thing what I told to Madam Asifa, you have to follow. Okay. Then we will move towards.
Sir, one dot, sir.
Ah.
Sir, can we perform this type of clustering for large data set? Like here only 20 genotypes is there. If we have 400, 500 genotypes.
You can try. You can try anything. It is not like I have shown that so that you can get the clarity. You can perform. Just for the reference, you can download some molecular weighting paper. In that, you will get a heat map with large data set also.
Okay, sir.
Yeah. So now just open that d_public Word file. Now the most awaited topic, that is cluster analysis. I am getting query from day 1. So finally I started on day 8. Open that d_public. Word file is there. And along with that, one Excel file, data file, that file name is cotton. So kindly save that Excel file in your working directory. And install the package BioTools. First I will run total command. One by one first see, and then you can do. First I will show you. First I will clear this everything. So first of all, I will import the data set, as the working directory is already set. So I have imported the data set. As I have already installed the BioTools package, I will directly run this library. Okay. Then see, first step is you have to separate the dependent variables. So here, if you open this Excel file, you will get multiple columns like genotype, replication, and then this traits like Symphodia, Boles, Bole weight, cotton yield. So the cluster analysis only we want of this independent variable. So the fixed means your number of genotypes are fixed and replications are fixed. So you have to separate that. So total here, total columns are 6. So we have to separate these fixed columns, that is genotype and replication. So that's why we are giving this command. Like here, to consider the data from 3rd column to 6th column only. Okay, so you can see here data will start from Symphodia, then Boles, Bole weight, and seed cotton yield. So that your fixed variables are gone, genotype and replication. So after that, next is model for MANOVA. I will run it and I will afterwards, I will tell what is MANOVA and everything. So here we'll set the model. So here you can see these genotypes and replications, the same as we represented in the data set. Then after setting model, we will run this summary command. So we will get the model in form of the tables, numbers. Then now what is SSD? So if you want to ask the software about anything, so just you have to type the question mark and after that anything, means like here in case SSD. So here on the right hand side it will give SSD the details. Like SSD means SSD matrix and estimated the variance matrix in multivariate model. So here it will give a total detail.
Sir, yes, SSD means single seat descent?
No. Don't go in breeding, pure breeding. This is we are dealing with biometrical genetics.
Okay, so
what is SSD? What is SSD is here. That's why I am telling that same thing. I want to know what is SSD, so I gave this command.
Okay.
So if you can see on your screen, everything detail will come on right side. Separate document will come. So likewise, this total and this covariances are there. Then percent contribution. So many MSc scholars are there. You know very well. One last table is there, that is trade serial number, trades, percent contribution. So for that, this is the command. So as we have for minimum trades, so contribution is there. If you want to plot this contribution also, you can plot. Likewise. So see. Seed yield is giving 82%, boles 5%, bole weight 6.1, Sympodia 6.8. Percent contribution in diversity. So now next is Mahalanobis distance. Sorry, one trick I missed. So simultaneously here, this is your data set. Simultaneously, you need to prepare one sheet. Name is average. So here genotypes. Here I forgot that average. I will do it quickly here. Yeah, so here you can see. I will delete this from the mean values. So yeah, so here Actually, we have to prepare the two files. First is in first sheet, that replicated data will be there, and in second sheet, averages, mean values. So I will I will start this from start. So in this, you have to import the data set twice. As we have prepared the two sheets, so you have to import the data set twice. So just you can see from as it is an Excel file. So now that you have imported, so how?
Sir, please share that file in WhatsApp group also.
Yeah, just let me complete. Let me complete first.
Yes, sir.
Yeah, so just you have imported. I will do that. Wait. Yeah, so please use this latest cotton file. Yeah, so now here I have selected the file, but we have two different sheets. One is replicated and second is mean. So here one sheet option is there. So from here you can see your Excel file is having two sheets. One is D square, that is replicated, and second is average. So first we will import the D square sheet. And after that, with same procedure, we will input average. So as now, both are there. Both we have imported. So then again, after importing, just as already biotools are there in my software, so I will just run the library. So as I have told you, we need to separate that genotype and replication from our sheet 1. So it is, we will give this command. First only with this first command only we will run, and when we need average, we'll import the average file. So it is as I told you, your fixed variables are gone. Then next is MANOVA. Then your MANOVA and covariance will come. And then as we have seen, the contribution. So after that, after contribution, we need to calculate the Mahalanobis distance. Now our replicated sheet work is over. So now we'll input our mean data. That is average. So with that average, we'll calculate. So in this command, you can see -1. So as that first column is genotype number, so we need to remove that. So we are giving the command -1. Average is there, no? What happened? Yeah, so be careful to change the sheet name from here. I think it is taking directly cotton. Yeah. Then we will follow Tocher's method. So here total 6 clusters. And this is your cluster distance. And then this again one modified torches. In this modified method, it is showing 5 clusters. So up to this, just try it. I will give the explanation about MANOVA.
Sir, when in average the error was coming, so what you did, sir?
So simply make 2 separate files. One with the name cotton and one with the name average. That is the one option.
Okay, sir.
And second option, here you can see. So in this command, if you have your both sheets in same file, so in place of average in this command, write the name cotton. So both options are there.
Sir, I have a question for D-square
sir.
analysis. For D-square analysis, is it always in the form of a table, or there's a graphical representation also for D-square analysis?
Yeah, after this cluster diagrams will be there, sir.
Okay, thanks.
So like this, first this percent contribution table and diagram. So likewise, this distance also will come in diagram, like our dendrogram in form of dendrogram.
Okay, sir. Thank you.
Sir, kindly show the coding, sir.
It is that Word file, no, madam. You can access from your from that WhatsApp group. Only one single Word file is there. D__public.
Sir, I've shared you one screenshot number ending with 157.
157. So, madam, which sheet you imported?
Sir, I have imported both sheets.
No. Do one thing. Import the data. Just I will show you. So just import the data from Excel. First, select the file. And here see the one sheet option is there, madam.
Yes, sir.
Yeah, so click on that and click on the replicated data sheet only and import. And now you can run the command.
Okay, sir.
So let me know after completion or if whatever errors are there also. Yes, madam.
Sir, when I was running the command for the Mahalanobis distance, the code was not working.
Yeah. So what
because
is the
there was
error?
an object average not found.
Yeah. So do one thing. Import.
Yes, sir.
Go to Excel. Select your file again.
Okay.
Select your file again and go to sheet. Go to sheet and select the average sheet. And then
Sir,
import.
at the initial, we have selected both of the sheets. Again, we have to import this sheet.
You have to go different because those two sheets are different, madam.
Okay, sir.
Yeah.
Sir, I want to check all the code again.
Yeah, so any error up to this?
Yes, sir. I have sent you on 905 number. Please check.
Yeah. Number, yeah, madam.
Yes, sir.
You got it?
No, sir.
Actually, I think my mic was mute. So you need to do data importing again with a sheet average.
Sir, I have done that.
Then now you can start that commands with the original name of the file. In place of average, just write the original name of the file.
Okay, okay, sir.
Sir, how we will get the total diagram?
Sir, please show your R Studio screen.
Yeah, madam, diagram also we will see. Don't worry. First, let everyone complete up to this.
Okay, sir.
Today is the 7th day. 10-day program is there. No, online program. FDP scheduled offline. Lot of every programs.
So that Mahalanobis distance is still not working.
Can you share this photo?
Yes, sir, I have shared. Number ending
1
with
minute.
547.
Gopalji, I also shared my photo. Error.
Yes, sir. Just give me a minute. Yeah, so number ending with 547.
Yes, sir.
Just replace that average word with the word cotton.
Okay, sir.
And then run. And then run.
In the last command.
Yeah.
Oh.
Tushar sir.
Haji.
Yeah. First import the Excel file with your replicated data sheet only.
Okay, okay, okay.
Yeah, yeah.
Sir, number ending with 417. Sir, number ending with 417.
1 minute, Aniket, I will say. Problem that I will add this. Okay. Yeah. Aniket.
Yes, sir.
So Aniket, can you send me your input file? So number ending with 852, whether you have run the library biotools command or not. This biotools command. So just check it.
Sir,
Yes.
sir, while
Sure.
importing the second, yes, sir. Sir, while importing the data sheet again for average,
Yeah.
I changed the name of cotton from there, so the data works, sir.
No. If that name is cotton, also I did with cotton only, no? See,
Yes, sir. Yes, sir.
no
Yes, sir.
problem.
Yes, sir.
If that's
Okay,
why
sir.
I told you to avoid
Yes.
to avoid confusion, just prepare two separate file. One file is
Yes,
replicated
sir.
and
Yes, sir.
another file is average. So this
Yes, sir. Yes.
confusion will not be there.
Oh, okay. Okay. Sir, I share you one image, sir. Can you check, sir?
Yeah, correct only. I just saw
Okay.
yours.
Thank you, sir. Okay, sir.
So if to avoid this confusion, just at initial stages, you can prepare two separate files. So you will not have any issue.
Sir, hello. Hello.
Yeah, so 852, you have installed BioTools, but not loaded. Just load that package with library command. Now Tushar sir, import that file again and change the sheet name.
Okay.
And change the name also, it will show in the name of cotton. So instead of average, you need to write cotton. So everyone is clear up to this?
Yes, sir.
Yes, sir.
Yeah, so quickly I will tell you about that MANOVA. Yeah, 388, correct. So now here you can see as this MANOVA means it is nothing but multivariate analysis of variance. As we have seen analysis of variance in case of our different experimental designs. So this MANOVA is multivariate analysis. So it is nothing but same like analysis of variance, but this MANOVA is used when there are two or more dependent variables. So that means it will compare. It will not compare, it will determine if the mean differences among the groups are statistically significant or not. As we have seen, as here, we have prepared the clusters. So it will determine the mean differences, whether it is statistically significant or not. If you go to the MANOVA, you will see here, it is coming as a significant. And your replication differences are non-significant. So that is the ultimate aim of MANOVA. Yeah, and this SSD we have seen. So this SSD in case of this diversity analysis means sum of squared differences. So that means it is the cumulative square differences between the two means. If suppose genotype 1 and 2 across the traits, so it is nothing but squared differences between the mean of those two genotypes across the traits. That is called as SSD. So that is about MANOVA and SSD. And this is,
can you repeat
this is
once?
Yeah. So MANOVA you got clear? Multivariate analysis of variance.
Yes, sir.
So it will compare whether your differences are significant or not among the combinations, whatever the genotypes. And next is your SSD. SSD is sum of square differences. So now what is the sum of square differences means what? Suppose there are two genotypes 1 and 2 and 5 different traits are there. So what this SSD will do? It will do the squared of the differences. Whatever the differences are there for those two genotypes for the trait means. It will do the square of that differences. Higher the SSD value, divergence will be more between the two genotypes. That's why we calculate those SSD values. Actually, commonly those SSD values no one will represent, because frankly speaking, if any student will analyze with anything new and if he will go to the respective supervisor, he will reject that. I am speaking frankly. If anyone will feel bad, it's really sorry, but this is fact. Many MSc students and PhD students will agree to my statement. So don't think too much about this SSD. Okay, so up to this it's fine.
Yes, sir.
Yes, sir.
Yeah, so number ending with 852.
Yes, sir.
I told you, I just mute your mic because that voice is coming ego. Just listen. I told you to run library biotools command, but you did installation of mass package. I will WhatsApp you. Don't worry. Okay. So
Sir,
now,
how to perform this in augmented design?
so if augmented design is there, so just you need to use average. You can't use the replicated values. So from average only you need to calculate. As there are no replications, so you need to take the mean values of check only. And you need to form the mean values. From that only you can do the cluster analysis. If you want an augmented design, just you can call me tomorrow. I will tell you.
Okay, sir. Sir, if possible, please give us that script.
Okay, okay.
If any change in. Okay,
Yeah,
sure.
so as we have lost that 2 sessions, so tomorrow and day after tomorrow also we will take. So now tomorrow, box plots, heterosis and combining ability, these 3 topics we will cover, and last day we'll finish this, our most awaited, that is genome-wide association studies by using GAPIT and farm CPU. So meanwhile, just open your chat box. Just download the Tassel software in your laptop. I will share the link.
Sir, kindly share it on WhatsApp too.
Okay, madam.
Excuse me, sir.
Yes.
Sir, please also tell the command how we can form the different dendrograms.
Yeah, tomorrow we will start with that only because that is left, no?
Yeah, sir.
Yeah, so just keep this Tassel software, just download it and keep it so that it will save our time. And that commands and everything I will share. So whatever the required packages, so just keep it installed. So means we will not waste any more time in installation so that we can complete that.
Sir, Gapit and that farm CPU is also a software.
It is a package, madam. Both Gapit and farm CPU, both are the packages.
So this we will use in our studio.
Yeah.
Okay, sir. Okay.
There are now, if you go through, I will share that Gapit manual link also.
Sir, since Jivas is a very vast topic, so will it be possible to complete in one day?
Yeah, that's why I'm telling you. Analysis is not vast, madam. It will take time to understand.
Okay, sir.
For errors, as we have already told, if any error or doubt, just you can put message in that WhatsApp group. Later also, whenever I will free, I will reply, so don't worry.
Sir, we have to download Tassel 5 Mac OS or 64-bit, which one?
It is depend according to your system.
Okay.
So keep this and go through this link. One link also I shared of Gapit. So go through these things. Because if you keep these packages already installed, we can finish it quickly and we can start that Jivas and everything tomorrow itself. By spending 1 hour for this heterosis combining ability box plots at 7 o'clock, we can start the Jivas. So we'll get 1.5 days. Hence we'll get almost 3 hours for that. So whatever the packages required for heterosis combining ability in early morning, I will share to you. So please keep it installed. So we can concentrate on this.
Excuse me, sir.
Yes.
Sir, also please save the script of correlation and path diagram so that we can perform that.
Yes. Okay. So this remaining things, whatever is 2-3 points for representation box plot and this correlation, I will send. That will take 5-10 minutes. That will not take more than 10 minutes. So our major topic is, first is heterosis combining ability and second is GWAS. So GWAS is more major.
सर आपने जो दूसरा लिंक शेयर किया है व्हाट्सएप पे उसका क्या करना है उसमें से क्या डाउनलोड करना है?
So just open it and go through everything. So if you open it, you will get the diagrams like interactive Manhattan plots, whatever we can generate. So just explore that website up to the extent maximum extent up to which you can explore, just explore it.
Okay, sir. Thank you.
Whatever the doubts you can note down, we'll discuss tomorrow and day after tomorrow.
Okay, sir.
And this Tassel software also, just explore it. Based on your system, links are there. So download it. User guide is there. Okay. Okay, so tomorrow we'll finish this D square representation. That is your cluster diagram. Then correlation and then heterosis combining ability, and we'll try to start the GWAS tomorrow itself.
Okay, sir.
Yeah.
Sir, is there any need to download anything from this Gapit website?
Yeah, you can download. If you will download this user manual, if you go through this user manual and that some packages are there, if you download it, it will save our time, sir.
Okay, sir. Thank you.
Yeah.
So yesterday we requested to share
Thank you,
the recorded version.
Yeah, I think today he will share. I will ask him. Bibakar sir. Because he told me in the morning that he will share, but I don't know exactly. Vivakar sir, you are there?
Sir.
Yeah.
Yes, sir.
So they are asking about what you told yesterday.
Sir, yesterday I told you that from the next training onwards, daily you all will get the recorded session.
No, we are asking about the previous ones because it will be help us to fact. No, only 2 or 3 days are left, so that will be.
Sir, still 3 days are left for this program. Not only 2 days, 3 days are there. Don't worry for that.
Okay, that the whatever the 6 days or 7 days has happened, can you share? It will be helpful for us to recap it.
Okay, sir. We have already a message in the group many times, and once again I'm repeating. Those who will be having the 75% attendance, we are going to say to them.
Kindly have a look and do it, please.
Daily attendance is being taken, sir. Based on the attendance, we are going to share it each and everything.
Okay, please.
Sir, I have one problem. Can you explain me in brief diversity and variability, some differences? I know about some.
Akhil.
Yes, sir.
Yeah, just give me a call tomorrow morning in between 9 to 10. I will tell you.
Okay, sir. Okay, sir.
Okay. So we will see. We will meet tomorrow 6 o'clock.
Okay, sir.
Okay, sir.
Thank you.
Gopal
Thank you,
sir.
everyone. Tushar sir.
Whatever packages we required for tomorrow's session, can you share the list?
Yeah, I will share the script directly for heterosis combining ability, and for molecular analysis, I have already shared the links in WhatsApp group.
No, I downloaded that one. everything, but I never get to some packages list.
That I will copy from that manual and I will share to you.
Okay, okay, thank you.
In the WhatsApp group, I will share.
Yeah, yeah, thank you.
Okay. Okay, thank you everyone. Thank you very much.
Thank you, sir.
Thank you, sir.